Welcome to Docket Decoder. If you enjoy our content, please do us a favor and hit that like button or subscribe so you can stay up to date with the latest court filings. In the District Court of the 2nd Judicial District of the State of Idaho, in and for the County of Latah. Affidavit of Leah Larkin. 1. I am an adult, over the age of 18, and I have personal knowledge of the facts set forth in this affidavit. 2. I've been engaged as an expert in the above entitled matter since July 27, 2023. 3. I am a genetic genealogist, having practiced genetic genealogy since 2014. My educational background is a bachelor's degree in biology and a PhD in botany. My curriculum vitae is attached. As a genetic genealogist, I have a clear understanding of how genetic genealogy works. I have developed tools that are in widespread use by genealogy practitioners. 4. Genetic genealogy is best described as the use of DNA data to evaluate biological relationships. There are 3 categories of genealogical DNA tests: Y chromosomal DNA direct paternal line only, mitochondrial DNA direct maternal line only, and autosomal DNA, all branches of a pedigree. A genetic genealogist integrates information from these DNA tests with genealogical documentation to reveal or corroborate relationships. 5. Genetic genealogy primarily uses autosomal DNA tests that were originally designed for biomedical research. Since 23andMe brought their health test to the consumer market in late 2007, Family Tree DNA, Ancestry DNA, MyHeritage, and a handful of smaller companies have launched their own genetic genealogy products. These companies all provide genealogy tools to their customers on their websites and also produce a raw DNA data file that the customer can download. The raw data file contains the genetic profile for that customer. This genetic profile is not the same as an STR profile that is commonly uploaded to CODIS in a forensic DNA analysis. 6. Most of the human genome is identical across all people. Only the DNA positions that vary between individuals are useful for genealogy. These variable positions are called single nucleotide polymorphisms. The direct-to-consumer genealogy companies use a type of test called a microarray that samples roughly 600,000 of these DNA SNPs. Unlike the STR markers used for matching in CODIS, SNPs can convey information about medical and physical traits, as well as biological relationships to close and distant cousins. 7. A microarray SNP profile is sometimes called a kit. Once the lab test is complete, the genealogy company compares the new kit to those already in its database, looking for long stretches of SNPs that are compatible. The company then presents these matches in a list sorted by the amount of shared DNA measured in centimorgans. 8. A standard DNA microarray requires approximately 200 nanograms of quality DNA. That quality and quantity is often not available from crime scenes or degraded human remains. Instead, specialized laboratories can generate an SNP profile through a more complex process. First, they attempt to sequence the entire genome using next-generation sequencing technology. This technology works a bit like skimming while reading a document. On the first pass, NGS technology will not capture all of the data, and it may make mistakes. NGS involves repeated passes called coverage to get more accurate results. For human genome sequences, 30 times to 50 times coverage is recommended. 9. Once the NGS file is obtained, it must be manipulated through bioinformatics to make it compatible with the genealogy databases. The extra data must be stripped out to just the SNPs that the genealogy companies test, and missing or ambiguous data must be inferred using statistical methods. The kit is then uploaded to a genealogy database and evaluated. A poor quality kit might have too few matches, or it might have phantom matches that are not real measures of relationship. Often, the bioinformatics step must be repeated. This trial and error process can take several tries to produce a kit that works well in a genealogy database. 10. Only GED match, family tree DNA, and some smaller entities allow crime scene and human remains samples to be uploaded. The terms of service at Ancestry DNA, 23andMe, and MyHeritage prohibit forensic investigative genetic genealogy in their databases. However, in the absence of an effective oversight, forensic genetic genealogists are on the honor system to obey the terms of service and the Department of Justice interim policy on forensic genetic genealogy. 11. Each of the genealogy databases compares the user's DNA data to all of the other data files in their database, then presents a list of DNA matches who share meaningful amounts of DNA. The match list includes the match's name or alias, how much DNA they share in centimorgans, and occasionally a link to a family tree that the match has voluntarily provided. 12. The genetic genealogy databases are siloed from one another. If you tested Ancestry DNA and your sibling tested 23andMe, you will not be matched to one another because you are not in the same database. GEDmatch is a third-party site that functions as a genetic genealogy commons. A user can upload their raw DNA data file from their testing company and find matches to people who uploaded to GEDmatch from different companies. Like GEDmatch, Family Tree DNA, and MyHeritage also allow uploads of raw data files. Ancestry DNA and 23andMe do not. 13. Broadly speaking, the more DNA two people share, the more closely they are related. The correlation is not perfect, though. Any given centimorgan amount can represent more than one possible relationship. The testing companies suggest probable relationships, but experienced genetic genealogists typically use online shared centimorgan tool, shown at right for a hypothetical match of 200 centimorgans, to see mathematical probabilities of different relationships for a given centimorgan amount. Note that there are nearly 20 possible relationships listed for a match of 200 centimorgans, which is considered a fairly close match. 14. Adoptees have used genetic genealogy DNA tests to identify their biological families for roughly 15 years now. The same methods used for people with unknown parentage can be used to identify forensic samples from a crime scene or unidentified human remains. Unlike standard forensic STR tests, which are used to identify individuals, genetic genealogy testing identifies possible relatives. 15. First, the genealogist attempts to build family trees for the DNA matches of the person of interest, starting with the closest matches. Relatively few users at GEDmatch and Family Tree DNA post their pedigrees there, so the genealogist must build trees for them. We attempt to identify the match using their screen name and email address. Then, we search public records, social media, obituaries, news articles, and genealogy websites to build out their tree through their parents, grandparents, and so on. Most genetic genealogists build these so-called research trees at Ancestry.com. 16. The goal of building trees is to figure out how two or more matches are related to one another. For example, if the person of interest matches two people who share a great-grandparent couple, making them second cousins to one another, the genealogist now knows the branch of their tree is relevant to the search. The person of interest could be descended from that couple, or the connection could be one or more generations further back through either the husband or wife in that couple. 17. Once several of the DNA matches have been connected to one another, the genealogist must figure out how the person of interest fits into the tree of those matches. We use age, sex, geographic location, and other circumstantial evidence alongside the DNA-based relationship predictions. A statistical tool called What Are the Odds can analyze multiple DNA matches together to evaluate where the person of interest best fits into the tree based on the amounts of shared DNA. 18. What are the odds is not intended to give a definitive answer. Rather, it points the genealogist toward the most likely branches in the tree for further research. The tool is also not appropriate for all circumstances. For example, it is not intended for populations that married within themselves, for double cousins, or when most of the matches are below 40 centimorgans. 19. The genealogists need to do this for both the maternal and paternal sides of the person of interest pedigree. Often, this involves building dozens of trees and performing several what are the odds analyses. We are looking for instances where a descendant in one DNA family tree married a descendant in another DNA family tree, because those unions point to where the person of interest might fit into the tree. Often, the best we can do with an existing DNA matches is to focus on a set of cousins as candidates. Then, more DNA testing is required. 20. This process can vary in complexity depending on the individual starting point. In doing this type of research, the genetic genealogist will generate numerous documents to ensure an adequate paper trail. This paper trail can include the list of DNA matches, the research tree with genealogical documentation, public record searches for members of the DNA family, correspondence with DNA matches, descendant diagrams showing how the DNA matches are related to one another, and what are the odds analyses. This documentation is necessary and important for the following reasons. DNA matches sometimes hide their profiles. An error in the tree can mislead the genealogist, and the descendant diagrams and what are the odds analyses are usually updated repeatedly during the search. 21. As a genetic genealogist, I have learned about the power and the privacy implications of genetic genealogy. The tests themselves are designed to reveal biomedical information and can also reveal family secrets about the tester. In many cases, private information can be inferred about the DNA relatives of the tester as well. For those reasons, leaders in genetic genealogy community developed standards that emphasize consent and privacy. 22. I am aware of the Department of Justice interim policy to limit when forensic genetic genealogy can be used and which databases are accessible to law enforcement. It is possible for the databases to be utilized in a way that circumvents these core principles. Notably, I am aware of A case in which the chain of custody failed and the wrong S&P profile was sent to the wrong client. B. Investigative genetic genealogists uploading S&P profiles to a forbidden database in violation of that company's terms of service and the Department of Justice interim policy. C. Forensic genetic genealogy being used for a case that did not meet the Department of Justice threshold. D. Investigative genetic genealogists using security loopholes to see DNA kits that are opted out of forensic matching at GED match and family tree DNA. E. A case in which an SNP profile was performed on an innocent woman, a potential Fourth Amendment violation of her right to privacy, and uploaded to GED match without her knowledge or consent. 23. Having access to the data and methods used to identify someone will provide answers to A. Compliance with Department of Justice policies. B. How a DNA sample was handled from the time of collection through its forensic genetic genealogy testing. C. The process of SNP creation. D. The use of the SNP profile. E. The use, or lack thereof, of loopholes and violations of terms of service to the various genetic genealogy databases. Further, your affiant saith not, dated this 8th day of August, 2023. Leah Larkin.